Berlin has welcomed him as a visiting scientist, and he has also been invited to talk at ICTP in Italy and Lautern University in the United Kingdom. His contributions have been recognized with prestigious awards, including the most cited author award in India and the most trusted referee award from the Institute of Physics, European Physical Society. Dr. Banerjee is the editor of Promano, Journal of Physics, and associate editor of Frontiers of Network Physiology. And he is also a fellow of the Institute of Electronics and Telecommunication Engineering, India. We are truly honored to have him with us today. On behalf of the organizers and all participants, I extend a very warm welcome to you, sir, and express our heartfelt thanks to accepting our invitation to share your knowledge and expertise with us. Over to you, sir.
Thank you, Dr. Ghosh. Rather, I should call you Devarathi. Thank you, Devarathi, for your very generous introduction.
I'm always available for you, sir.
Parvati and other coordinators for inviting me over here. Okay, let me share my screen. So, is the screen visible?
Yes, sir. Yes, sir.
Okay, thank you. So, this is the story of my talk. I will be talking about, in general, in a broad way, about nonlinear dynamics, how order counts in chaotic dynamics and other things. And these are three synthetic figures. You can see that one is taken from a CRO, one is the representative of pattern formation from zebra, and other is devastating tsunami. How these three pictures are related with each other that I will be talking about. And my apology to the experts because I will be presenting my talk in a broad way, in a pedagogical way, and my talk is meant for the students and early researchers, not for the specialists. So, in advance, my apology to the very experts actually. Now, before I start, let me make it clear what we mean by nonlinearity. So, we are talking about nonlinear dynamics. So, nonlinearity means anything that deviates from linearity, that is called nonlinearity. So, this is one of the examples of linear dynamics, that is straight line. Anything that deviates from straight line is nonlinearity. So, this is the very basic representation of nonlinearity in conductor. We have Ohm's law, that is E is equal to IR. It obeys linear dynamics, and in diode, say, we have exponential curve, so this is not nonlinear. This is not linear, it is rather nonlinear. Now, what do you mean by nonlinear dynamics? Dynamics we all know, but what is nonlinear dynamics? I think there is some echo problem. Okay. So nonlinear dynamics means in a dynamical system, if we do not discard the nonlinear terms, then the total dynamics is called nonlinear dynamical system. So for the last 200 years, starting from Newton, whenever we saw a nonlinear term, we used to linearize them or describe them, and we prefer linear dynamics for our sake of simplicity. For example, in our school days, we learned simple pendulum and the dynamics or the mathematical expression of the simple pendulum looks like this. And to this actually suffers a severe constant. For example, the angle of radiation should not exceed 4 degree, etc. So all those constants are there, but this little girl swinging in a swing, she doesn't obey the equation of simple pendulum because she does not constant her between or into the domain of 40. So for her, the dynamics is this, the mathematical expression is this, and you can see the sine theta term. The sine theta term makes this dynamics of a simple pendulum non-linear. So this is not linear, and if you want to solve the exact dynamics of a simple of a pendulum, or not simple of a pendulum, then we have to know nonlinear dynamics. The formalisms of nonlinear dynamics. So is this the only motivation that we want to study is pendulum? Not that, because this pendulum equation is applicable everywhere. If you talk about superconducting Josephson junction, the equation is resembling the equation of a pendulum, nonlinear pendulum. So enough motivations are there to study these pendulum equations. Now, what about oscillations? So oscillators are everywhere. If we talk about oscillations, every oscillators you see in nature in your daily life, starting from your heartbeat to the oscillations, electromagnetic oscillations coming to your mobile phone. So all those oscillations are the byproduct of nonlinearity and dissipation. And it was given by Vanderpool, Professor Vanderpool, in 1920s. And this is the second order differential equation, the generic equation for any nonlinear oscillations that you see in nature. So this is a gift from a physicist and electrical engineer who first gave the exact mathematical model of a nonlinear oscillators. And their manifestations are everywhere, as I told you, that an ensemble of atomic oscillators that we call laser. We talked about Josephson Johnson. In Josephson Johnson, we have two superconductors. In between, we have a sandwiched insulators and the very high frequency oscillations. That mathematical model resembles the model of a pendulum. Electronic oscillators, we all know in colleges and universities, students are more conversant with the electronic oscillators. They study RC basic oscillator, Bell oscillators, and believe me, all those oscillators are nonlinear. Our heart is a perfect example of oscillator. It beats over 1 lakh times every day, and the beating is very perfect. This is one of the examples of chemical oscillations. The concentration of a particular reactant oscillates with time. This is an example of ecological oscillation. The population of predator and prey, for example, fox and rabbit, they oscillate in a periodic manner. So this is the very famous Rosenberg-McArthur model representing the ecological model of the population of predator and prey. Our nervous system, in our muscles, electrical signals, that is called action potential. Those action potentials actually are in the form of oscillations in voltage and current, and their mathematical model is given by Pigeon-Argonaut model, Oskin-Husky model. Oskin-Husky actually got Nobel Prize neural oscillations. And this is just one representative example of neuronal oscillator model. So all these oscillators are mainly periodic, but there exists one particular oscillation that is called chaotic oscillation. So what is chaotic oscillation? Chaotic oscillation means a particular type of oscillation that comes from a deterministic system or in long range that is unpredictable. So if suppose if I have an equation, this particular equation, this since we have mathematical model of this equation, therefore the equation is representing a deterministic system. But for initial condition, very little bit, the output will be totally different. So chaotic oscillation is, we may say that unpredictable oscillation coming out from the deterministic system and which is unpredictable in the long term and which is sensitive to initial conditions. Although the variables x, y, z are deterministic, you can see the noise-like behavior. But in phase space, this is x versus z. In phase space, if you plot the phase space diagram, you can see a particular order in the chaotic dynamics. So in time domain, it looks like a noise signal, but in phase space, geometrical space, you can see the order within the chaos. And this particular model, mathematical model was given by Edward Lorentz in 1963. We all believe in this particular code, what I cannot create, I do not understand. So if you want to understand chaotic dynamics, you need to study chaos in your laboratory. But the good thing is that to study chaos in your laboratory, you don't need a very expensive laboratory or very expensive instruments. You just need one CRO, maybe one laptop, and a few components, say open, resistor, capacitor, all those things, just you need. So in your laboratory, college laboratory, you can Common people say welcome. Okay. Sorry, we have got some network problem in our university. Now I think I'm signing in. Okay. Okay, so for what I was talking, this particular circuit you can implement in your college, in your university, and you can set this particular experiment in your physics lab.
Excuse me, sir, your slide is not visible.
Yes, please.
Your slide is not visible, sir.
Okay. Okay. Sorry for the interruption. Yeah. So I was talking about this particular circuit. You can solve that circuit equation using simplification and KVL. These are numerical results, and let me show you the experimental results. These snapshots are taken from simple CRO. So to implement chaotic circuit, you don't need anything special, any expensive instruments. And these are few examples of CRO snapshots taken by our students in our MSc lab. So this is the snapshot of video of chaotic circuit, Lorentz circuit actually. So this is one more example of the chaotic, the result of chaotic oscillator. Yeah. So this is chaos. Students get it from a chaotic circuit in their MSc lab. Therefore, you can always set experiments on chaotic circuits in your laboratory. And in T.P.S. college, you have the present professor, Dr. Devarati Bose. She is expert in setting these chaotic circuits. These are few examples of chaos from another circuits. So this is the total zoo of chaos we have got in our laboratory. Okay, up to this point we talk about oscillations and chaos. Now, before I finish, I will rapidly go into the other aspects of nonlinear dynamics, that is synchronization. Synchronization means if you have two oscillators and they share a common platform, they will oscillate in synchrony. There are several examples of oscillation. For example, car tires in a bush or tree tires in ignition, phase-lock loop that is used in your mobile phone. So in your mobile phone and laptop, you have phase-lock loops. Those phase-lock loops are working in unison, that is in a synchronous manner. Laser, the junction, sound of crickets, clapping in social gatherings. So all these are examples of synchronization. And let me show you one video of what synchronization means. So this is the example of synchronization. You have 32 metronomes, and those 32 metronomes are sharing the same platform. The platform is moving, so their energy is transferred. So those these metronomes actually share the energy to this common platform, and you can see that at present they are not synchronized, but as time goes by, they will be synchronized. So the synchronization is spontaneous, not forced synchronization. You can see that after 2 minutes, they are perfectly synchronized. In nature, we have several examples of synchronization, and synchronization deserves a 1 hour uh, talk by itself, but I will give in very brief what does synchronization mean. All the power grids in our country are synchronized. All the internet networks are working in a synchronized manner, and all those synchronization, although they occur in different biological agents, in electronic agents, in chemical agents, but they obey a single expression, mathematical expression. The expression like this. This is some kind of damped pendulum. The equation of damped pendulum. And this is nonlinear equation. You have sine phi term. There are bad sides of synchronization also. I will not go into those parts. So before I finish, I will discuss just two things, that is pattern formation. The pattern formation, patterns occur in our nature that was identified by Alan Turing in 1952 in his famous paper, The Chemical Basis of Morphogenesis. And we propose that the theory is something like this, that nonlinearity and diffusion, they are their interplay gives rise to patterns. So this is the common mathematical expression for pattern formation. This is the nonlinear term, and this is the diffusion term. Nonlinearity plus diffusion gives rise to this particular pattern. This pattern looks like cos twice x, that is black, white, black. This is black, white, cos x. This pattern, there is cos x, cos twice x, or pattern of cheetah or zebra that comes from this particular equation. And in the last but not least, nonlinearity plus dispersion that gives rise to solitary wave. The devastating manifestation of solitary wave is tsunami, and that this wave or this nonlinearity plus dispersion, this particular mathematical model was given by Portugal T.P.S in 1896, around 1890s actually, and the equation looks like this. This is the nonlinear term, and this is the dispersion term, not diffusion or dissipation. So this is the nonlinear term, and this is the dispersive term. Nonlinearity plus dispersion that gives rise to uh, solitary waves, and thus solitary waves, the velocity as a specific obeys a specific equation G H plus A that can be proved from this particular KdV equation. So in conclusion, we have three types of manifestation of nonlinearity. Nonlinearity cause dissipation that gives rise to oscillation, synchronization, that is the temporal variation of a particular thing, for example, voltage or concentration or population. Nonlinearity cause diffusion that gives rise to pattern, and nonlinearity cause dispersion that gives rise to solitary waves, that is solid. So before I conclude my talk, this particular slide is taken from Harry Sweeney, and he told us that there are two types of science, big science, that is LHC, large hadron collider, LISA, and ITER. So all these experiments, uh, there are thousands of scientists. It takes decade of times. It costs billion of dollars. So you cannot just start your project uh, incorporating this big science, but you can always start a particular project, a specific experiment in your college and university to this hands-on technique of science. It requires some basic instruments that are available in your college, and laptops and smartphones are there everywhere in your home. So to set a basic laboratory, you can, by setting a basic laboratory, you can contribute towards nonlinear science. So the conclusion is the world is merely nonlinear, and to understand nature, we have to explore nonlinear dynamics, and nonlinear dynamics does not need any so-called specialized lab or large collaboration. Only your passion and curiosity are sufficient. So thank you for your patience.
Thank you so much, sir. Now it's time for questions. Do you have any questions? Yes, sir. Yes, sir. Please.
Sir, good morning. Sir, how does resonance differ in non-linear system? Sir, may I audible?
Can you please repeat the question?
Sir, how does resonance differ in non-linear system?
So you are talking about material science.
Yes, sir. Yes, sir.
Okay. So as I told you earlier, in material science there are two fields that nonlinearity plays a big role. One is magnetic property. So you have hysteresis. Or the study of magnetic properties, hysteresis plays a big role, and hysteresis is a nonlinear behavior. So study of hysteresis and Josephson junction, those two fields heavily used nonlinear dynamics, and if you can incorporate nonlinear dynamics into those two fields, you can provide some new aspects of or findings in those fields.
Thank you, sir. Sir, I have one more question.
Yeah.
What role does nonlinear dynamics play in modern communication, such as optical fiber या wireless network?
Okay. In optical fiber, you need we need that a particular optical signal should propagate without dispersion at long distance, a few thousand kilometers. So therefore, we have to create such a optical fiber where solitary waves can be generated. Solitary waves means the wave that goes thousands of miles without any dispersion. So peacefully some kind of nonlinearity is incorporated in optical fiber. such that there should be no dispersion, number one. Number two, in encryption these days, encryption, secure communication system, chaotic behavior is being exploited, and there are several papers on secure communication system where you can see that chaotic time series are used.
Okay, sir. Thank you, sir.
Thank you so much, sir. We sincerely thank our esteemed resource person, Professor Tanmay Banerjee, for delivering this wonderful talk on the story of nonlinear world ordered within chaos. Your clear explanation and engaging session have enriched our knowledge about chaos, nonlinear dynamics, and synchronization. So I encourage all the students to explore this chaotic dynamics in your laboratory. As I mentioned, we need very few components to see chaos in our laboratory. So be chaotic. And thank you so much, sir, for this wonderful talk once again. Thank you.
Thank you all.
Thank you, sir. Before going for the next speaker, resource person, I just formally welcome Professor Chittaranjan Sinha from Indian Photobiology Society. He is with us, and welcome, sir, to T.P.S. College. Our next speaker is Professor Jyotirmoy Das from Indian Association for the Cultivation of Science, Bhatnagar Awardee and Sandayanti Fellow Awardee. Ma'am, are you there, ma'am? Hello. Yes, ma'am. Are you there, ma'am? Ma'am, please unmute yourself. Ma'am.
Can you hear me?
Yeah, ma'am. Well, very good morning, ma'am, and thank you for accepting our invitation to this international seminar on recent advancement in basic applied and material science in 2025. We are in the second day, and before going to your presentation, I want to just introduce yourself first. Then I will request you to present, ma'am. Professor Jyotirmoy Das, she obtained her PhD in organic chemistry from IIT Kanpur. She was awarded Alexander von Humboldt Fellowship from Berlin, and then she was the postdoctoral fellowship at ESPCI Paris. She was also recipient of Marie Curie Fellowship at University of Cambridge. She first joined in ISER Kolkata as an assistant professor in 2009. Then currently she is senior professor in Indian Association for the Cultivation of Science. She has serving as an advisory member of several reputed journals like ACS Bioconjugate Chemistry, ACS Omega, Asian Journal of Organic Chemistry, Chemical Communication, and she is the section editor of Organic and Biomolecular Chemistry RSC Journal. And also she is one of the editorial board of Journal of Indian Chemical Society and of Bioorganic and Medicinal Chemistry Letters as an Elsevier journal. Her actually she was the recipient of different awards, and among them like DST Sarnajanti Award Fellowship, DBT Welcome Trust Fellowship, most prestigious Shanti Sarup Bhatnagar Prize in 2020, bronze medal in CRSI 2020, elected Fellow of Indian Academy of Science, Bangalore 2021. Her research interests include new organic transformation, supramolecular chemistry, and structure and function of nucleic acid. So today she will be discussing on therapeutic application of non-canonical nucleic acids. So, ma'am, now you can start, ma'am.
Yes, thank you, Susan, for your kind introduction. First of all, I would like to thank the organizers for giving me an opportunity to speak at the international seminar organized at T.P.S. College, Patna. And I would like to thank Susan, my PhD student, for the extended introduction. And today I am going to talk about nucleic acid secondary structures and their applications in therapy. So, as there are students, so I would like to show the start with this slide. As you know, that one of the important discovery in science is the structure of double helical DNA, and it was discovered by Watson and Higgs in the year 1953. And they won the prize, Nobel Prize in Physiology or Medicine in the year 1962. So what you see is that both the strands of the double helical DNA are held together by Watson-Crick type of hydrogen bonding. Guanine hydrogen bonds with cytosine and adenine hydrogen bonds with thymine. And these four alphabets A, T, G, C are also called the alphabets of life or the alphabets of DNA. So now the T who discovered the double helical DNA also proposed the central dogma of molecular biology, which states that DNA synthesizes RNA by a process called transcription, and then RNA synthesizes protein by the process called translation. Both these processes are important for the survival of cellular system. Now, if we can stop one of the states, that is transcription, by binding to the DNA structure, and then it would inhibit translation. So if we can do this selectively in cancer cells, the molecules that will bind to the DNA structure would be considered as potential anti-cancer agents because they can block both these processes and kill the cancer cells. So for instance, doxorubicin is a DNA binding drug. Here this structure shows the two molecules of doxorubicin can bind to the double helical DNA structure. However, since the double helical DNA is highly abundant, it is present in the healthy cells and in the cancer cells. Therefore, small molecules that bind to the DNA of the cancer cells, they can also bind and alter the cellular function of the DNA in healthy cells. So therefore, although double helical DNA is an early target for anti-cancer therapeutics for developing anti-cancer agents, but it is not used much because of the undesired side effects. Because many chemotherapeutic drugs, as we have also observed, that if we use any chemotherapy agent, then we have also side effects. So therefore, it is an important task to identify and target alternative targets. So in our lab, we are looking for DNA structures which are not double helical, but it is like a DNA sequence can adopt a four-stranded secondary structure called DNA quadruplexes, and its complementary series DNA sequence can also adopt an I-motif secondary structure. So now let us look at, we know that guanine hydrogen bonds with cytosine, but DNA also contains G sequences and its complementary C sequences. So these sequences can adopt these four-stranded secondary structures, and these G sequences can form this. This is called also higher order non-canonical DNA structures, because here guanine self-assembles with itself, that is guanosine hydrogen bonds with itself by using 16 type of hydrogen bond. The I motif, the series sequence also adopt these post-transit structures, and these are called I motifs because the cytosine hydrogen bonds with itself and they contain this intercalated cytosine base pairing which is due to coordination of one of the cytosines under acidic conditions. So both these G quadruplexes and I motifs are found in the cellular system by using specific antibodies and they are now considered as potential targets for cancer. So in our lab, we have been working, designing and synthesizing small molecules to target DNA quadruplexes which are present in the cancer-causing genes. One of the potential cancer-causing gene is CMYC quadruplex, CMYC oncogene, which is overexpressed in many cancers like acute lymphoma, lung, and breast cancer. And this gene contains a gene quadruplex causing sequence. And in our lab, you can see we have synthesized these small molecules which are relatively easier to synthesize. And these are aerosol based and carbazole based compound. And in our lab, we have developed two major classes of compounds. One is aerosol based and the other is carbazole based compound. These compounds can bind and stabilize DNA quadruplexes and can inhibit the CMYC transcription in cancer cells. As I have shown you, two different processes, transcription and transcription. If a ligand enters the cell and binds to the DNA structure, it has the ability to stop transcription. And since no RNA will be synthesized, then no protein also would be synthesized. And therefore, it will lead to the death of a cancer cell. So these are small molecules which can be synthesized in the lab by using simple alkyne and base addition, but they can bind and stabilize different DNA quadruplexes present in the cancer-causing genes and also can kill cancer cells. And this is another class that is hydrogen-based peptides that can also form ion channels, can increase sodium and potassium levels, and so promising anti-cancer activities. However, it is not that easy to synthesize and identify a ligand that can selectively bind to the DNA structures. So always rational design and synthesis of a ligand for a biomacromolecule is quite challenging because many reported compounds are poorly soluble in water, they lack cellular permeability, and they are difficult to synthesize. And we also wanted to design ligands that are selective for DNA quadruplets over double helical DNA. And also, we can also identify ligands that show selectivity between different quadruplet structures. And moreover, we also wanted to design ligands they are fluorescent so that we can track and monitor DNA quadruplexes in living cells. So finally, the most important question that whether a DNA binding ligand that show anti-cancer properties due to the regulation of gene expression, that is, do they really inhibit the transcription and translation? We also wanted to gain insights into the mechanism of regulation of gene expression. So with this backdrop, what if the biological target can synthesize its own molecules? Is it possible that the DNA can synthesize its own inhibitors, own binders? So the Sharpless and co-workers, they have demonstrated that an enzyme like acetylcholine esterase can synthesize its own ligand from a polar alkyne desired substance. So this approach is commonly known as in situ click chemistry or target guided synthesis. As the target, biological target itself synthesizes its own compound. As you all know that the couple one catalyzed alkyne desired cycloaddition is known as classical click reaction that proceeds reduce selectively under simple reaction conditions, providing high yields of triazole compounds. But in this case, only those triazole compounds form that can bind to the enzyme or protein based biological target. So next, Bartolsi and co-workers use trade promoted 1,3 dipolar saturation and to label glycans in living cells. So they have used this to study membrane dynamics. And Bartolsi also coined the term bioorthogonal. So what is bioorthogonal chemistry? That is reactions that can quickly link molecules under physiological conditions. That is under cellular systems or under living systems. As you know that the Nobel Prize in Chemistry in the year 2022 was awarded for the development of peak chemistry and bioorthogonal chemistry, and which was shared by both Bartolzi, Melde, and Sharpless. So these are the salient features of bioorthogonal reactions, and the alpha and azide saturation is a good example of bioorthogonal reaction because they produce a single stable product without generating byproducts. And moreover, for the bioorthogonal reactions, one must to design the alkyl and azide patterns so that they remain non-toxic to the cellular system and they are enough towards the biological processes. Now, with this backdrop, so let us let us come back to the in situ chemistry or target synthesis, which was developed by Chavez and Dubois. This method has been well explored for protein or enzyme based targets, but not explored for nucleic acid targets, that is for DNA and RNA targets. Peter Darman in the year 2003 has demonstrated that a double helical DNA can also assemble its own molecules. Like in this study, they have used KRP polyamides which are functionalized with alkyne acyl units. So these fragments bind to the minor group of double helical DNA and undergo 1,3 dipolar cycloaddition. So we thought, can we use DNA quadruplets to promote the 1,3 dipolar cycloaddition? So in this approach, the DNA quadruplets will select alkyne and azide fragments and they promote the metal-free 1,3 dipolar cycloaddition. We know that the copper is used to promote the 1,3 dipolar cycloaddition, or we have to treat it. But in this case, as we have to conduct the experiment under physiological conditions, that is aqueous medium or room temperature, so this is like the templated cycloaddition where biological target would select its own alkyne and azide fragments and bring into close proximity so that only those compounds would form that can bind to the biological target. Then the interaction of the newly synthesized compounds with the DNA structures was studied by using biophysical studies like rate-based melting, UV visible fluorescence spectroscopy, circular dacrosine, and isothermal calorimetry. We also study in our lab the efficacy of these ingredients in the biological system by using a series of biological assays. As you see, this is a complex reaction mixture, a mixture of alkyne and azide fragments and DNA targets. So, in order to isolate and identify the compounds, we immobilized high-level DNA tablets on gold-coated magnetic nanoparticles. So here we have used DNA, we have used nanoparticles, and we have also done the biological assays. So we have taken G quadruplexes, they are complementary I motifs as target templates. Then we have also taken a double helical DNA and a single stranded DNA as the control templates. And these DNA nano templates are characterized by circular dacrosine, UV visible spectroscopy, and stain imaging. So we anticipated that this DNA nanotemplates would provide a big surface area, large surface area, and due to the presence of more number of DNA templates, they could promote and accelerate the 1,3 dipolar cycloaddition. So this is the approach. We have taken a mixture of alkyne and azide fragments, incubated with the DNA quadruplex nanotemplate, Then we get sufficient time. We used an external magnet to isolate the DNA nanotemplate along with the newly synthesized parallel compounds. The ligand bound DNA was heated to release the newly synthesized compounds, and the DNA nanotemplate was recovered and recycled. So for this method, we have synthesized 4 different alkynes and 17 different azides. And if we combine this, it could lead to 136 possible triazole compounds. That includes both syn and anti-triazoles. By using our method, we have identified a triazolary carbazole that binds to the DNA polymerase, which is present in the promoter regions of C-oncogene, and it can inhibit the transcription in cancer cells. So this work combines synthesis and screening to one step. We don't have to synthesize a large number of compounds and screen, but we have identified a single compound from a complex reaction mixture. And then, due to the use of nanochemicals, we could easily isolate and identify the compound, and we could also reuse the DNA templates for subsequent reactions. And the compound selectively binds to DNA quadruplets over the double helical DNA and show promising anti-cancer activities. So next our plan, can we use this method to synthesize a macrocyclic compound? Then why macrocyclic compound? Because most of the reported compounds are linear aromatic or aliphatic. So then the question is, why macrocycles for DNA quadruplets? Because most of the classical G quadruplets binders are macrocycles, starting from polymystatin, TN, 4 and this oxazole-based macrocyclic compounds. Because of their large surface area, they show higher selectivity for DNA quadruplexes over the double helical DNA. And as you know that it is the synthesis of macrocyclic compound is quite challenging. It involves multi-steps, and finally, the ring closing state also requires optimized conditions and high dilution. So to synthesize the macrocyclic compound and identify the selective, excuse me, this requirement. So we have taken a series of higher containing DNA quadruplexes which are present in the cancer causing genes, including the quadruplex sequences present in the human telomere and controlled double helical DNA. And these DNA nanotemplates were immobilized from gold coated magnetic nanoparticles. And is it okay? Can you see my slide? Hello? Um, and then the macrocyclic so we have immobilized the DNA sequences and gold coated magnetic nanoparticles, and then we have treated them with the biofunctional alkyne and azide fragments, and after subsequent heating, we have isolated the DNA nanotemplate along with the macrocyclic compound, which was further heated to release the DNA nanotemplate, and by using HPLC and mass analysis, we have isolated the macrocyclic compounds. So we have synthesized bifunctional alkyne and azide fragments, and these fragments contain pyridine-based carboxamide units. And HPLC and mass analysis revealed the formation of the macrocyclic compound M1 by both human telomeric and semi quadruplex sequences. So this result shows that macrocyclic M1 can bind to both quadruplexes present in the promoted region of CV and human telomeres. And then secondly, since the product formation was higher by the CV than human telomere, it shows M1 could selectively bind to the CV quadruplex structure. So the next question is, what is the driving force of this DNA-templated macrocyclization reaction, and what is the reason behind their strong binding interaction? Why the macrocycle M1 was formed, and why does it bind to these two quadruplex forming sequences? So in order to address this, we have synthesized three more structurally similar compounds by using copper bond catalyzed alkyne and azides cyclogen. And the macrocycle M1 contains two amine side chains, M2 contains one amine side chain, which was derived from the alkyne unit. M3 contains one amine side chain, like that is derived from the azide unit, and macrocycle M4 lacks any amine side chain. We could crystallize the macrocycle M4 that side chains, and the crystal structure shows that the dimension of this macrocycle is quite comparable to the G quartet present in the DNA quadruplexes. So therefore, the planar G quartets present in the DNA quadruplexes provide a size complementary reaction platform for the macrocyclization of bioconventional azide and alkyne fragments over oligo and polymerization reaction. So next we have studied the interactions of these four macrocycles M1, M2, M3 and M4 with CV and stereoquadruplexes and double helical DNA. Due to their macrocyclic core, none of the macrocycles M3, M4 or M1 and M2 interacted with the double helical DNA. So that means they are highly selective for quadruplex over the double helical duplex DNA structure. And they, as in agreement with the target guided synthesis, that is in situ macrocyclization reaction, both M1 and M2 show the high selectivity for the semi quadruplex, and they also bind to the human telomic quadruplex. And both these M3 and M4 did not show significant binding interruption to the CV and stellar quadruplexes. So next we have studied isothermal calorimetry of both the compounds M1 and M2. The reagents show M1, which was synthesized by institutive chemistry, show a nanomolar binding affinity to the semi quadruplex and 1:1 binding stoichiometry. So these are the summary of our physical analysis, where we have taken several DNA quadruplexes and control duplex DNA, the fragments, the bis alkyne and the bis azide doesn't interact with the quadruplexes, but the product can selectively bind and stabilize the single quadruplex, and it even binds to a nanomolar binding affinity and 1:1 stoichiometry. So next, moving to the cytotoxicity assays, all these four macrocyclic compounds were selectively toxic to the HeLa cancer cells and then non-toxic to a normal kidney epithelial cell line. And moreover, it also shows the macrocycle M1 and M2 induce apoptosis in cancer cells. So next we have studied gene regulation process by using QRT2, which shows that the macrocycle M1 can reduce the CD mRNA levels in a dose-dependent manner. And Western blot analysis further shows that the M1 can reduce the CD protein levels. So therefore, M1 can reduce CD mRNA and protein levels in blood cells and can kill the cancer cells. Next, we have also studied immunocytochemistry. So in this assay, we have used BG4 antibody. BG4 is a G quadruplex specific antibody that binds to the quadruplex structure and produces red dots. So, since it produces red dots, it shows the presence of G quadruplex structures. So, this assay reveals that the macrocycle M1 is cell membrane permeable, it shows blue fluorescence, and it also localizes with the BG4. That means it binds to the G quadruplex structures present in the cellular system, and the cells treated with both M1 and BG4 increase the BG4 foci. So which shows that the molecule, that is the macrocyclic ligand, can bind and stabilize quadruplex structures in the cellular system. So I have given an introduction about bio-orthogonal synthesis. So next we thought, can we do this in situ chemistry in the cellular system? Can we synthesize M1 in HeLa cells? So both the bis alkyl and azide fragments are non-toxic to the HeLa cells. So we have created both these fragments in HeLa cells, and after 48 hours, the cell extracts repeat the bio-orthogonal synthesis of macrocyclic amines. And so that means the molecule, both the fragments can enter the cells, and the HeLa cells, like in HeLa cells, both CNIC and HTF quadruplexes are highly abundant. So they are cell membrane permeable, and the quadruplexes present in the HeLa cells promoted the 1T dipolar circulation, which was further monitored by BG4 antibody. That is, the fragments that filled the cells were treated with both the bis alkyl and bis azide fragments. We could observe an increase in BG4 foci, while the cells treated with only alkyl or only azide fragments did not show increase in BG4 foci. That means the macrocyclic M1 was synthesized in the cellular system that could stabilize G quadruplet structures and increase the BG4 foci. So here is a small video of this work. As we have discussed, DNA is mostly double helical, but the G-rich DNA sequences can adopt a four-stranded G quadruplet structure. In order to selectively target DNA quadruplets over the double helical DNA, we have synthesized bifunctional alkyl and azide fragments. So the G quadruplet selects its own bis alkyl and azide fragments, and only those fragments that come into close proximity and bind to the adjacent sites of the quadruplets undergo 1,3 dipolar bis cycloaddition and provided a macrocyclic compound. And this macrocyclic compound show high selectivity for the DNA quadruplexes over the double helical DNA, and also show promising anti-cancer activities. So this work was highlighted on the front cover, and this shows cancer cells can also act as chemical reaction vessels to make their own anti-cancer agents. So our next goal is, can we use a biomimetic template to promote the macrocyclization reaction instead of the DNA quadruplets themselves? So as initially I have discussed that a G-rich DNA sequence can adopt a G quadruplet structure, and they contain G quartet as the basic structural feature. And in our lab, we have demonstrated guanosine in the presence of phenyl chloronic acid when treated with POH can self-assemble and form a supramolecular hydrogel. And these hydrogels also contain G quartet-like structures. Therefore, the hydrogel can also mimic the topology of a DNA quadruplet structure. So we thought, can we use these hydrogels and promote this 1,3 dipolar cycloaddition reaction? So we have synthesized guanosine-derived hydrogen, and we have also synthesized cytidine-derived hydrogens. However, we observe that the macrocyclic M1 was synthesized from the corresponding bis alkyl and bis azide fragments in guanosine-derived hydrogens that contains G quartet-like templates, but no reaction was observed in cytidine-derived hydrogens. And TAM and AFM analysis revealed that macrocyclic M1 was integrated in the hydrogen network. So in the energy minimized diagram of the macrocyclic M1 is quite comparable to the G quartet, and therefore the hydrogen reduces the mobility of the bis alkyl and azide fragments, and proximally orient them to synthesize the macrocyclic compound, which is further analyzed by rheological studies and DSC studies. That is macrocyclic M1, which strengthen the gel network and also increase the melting temperature of the gel. So thus, I have shown DNA quadruplets can template macrocyclization reaction. We can synthesize macrocyclic compound in HeLa cells, and moreover, a biomimetic template, which is cost-effective material, can also template the macrocyclization reaction. And Not only the DNA quadruplex, we have also shown eye motif which are immobilized on gold-coated magnetic nanoparticle can select its own alkyne and azide fragments and promote the cycloaddition reaction. And a TAR RNA which is present in the HIV-1 genome can also be used as a template to synthesize a new class of peptidomimetic ligands which could be considered as promising antiviral agents. So, if I have 2-3 minutes more, or I have no time. Hello?
Yes, ma'am.
Can I get?
Yeah.
Okay. So very recently we are studying, can we target DNA quadruplexes in bacterial genome? That instead of cancer cells, can we use the same concept? That is inhibiting translation in bacteria. So the literature report suggests that DNA quadruplex structures are widely present in bacteria and viruses, and they also play a key role in replication, transcription, and translation of essential as well as virulence-causing genes. However, the DNA quadruplexes as drug targets remain unexplored in many bacterial species, including S. pneumoniae. This Streptococcus pneumoniae is one of the leading causative agents of pneumonia, septicemia that affects millions of people per year. And due to the increasing prevalence of resistance to the known antibiotics, we thought to develop an innovative approach that is targeting DNA secondary structures to combat antimicrobial resistance. Computational studies reveal that the S. pneumoniae contains three different G4, that is quadruplex ordering sequence, in which are located in the virulence causing genes like HSPS, RED, and PMO. All these three quadruplex forming sequences you can see contains G-rich quadruplex forming sequences. So we thought to synthesize a series of compounds and target these quadruplexes to inhibit the virulence in S. pneumoniae strains. So we have synthesized several compounds and finally identified these anthracene-based compounds that binds to the quadruplex forming sequences present in the PMRA, HSBS quadruplexes, which are present in the S. pneumoniae genome. And this ligand N1 also shows selectivity plus PMRA. That is, PMRA quadruplex is present in the PMRA drug efflux. That is, this quadruplex and this gene is responsible for releasing the antibiotics, and therefore the antibiotics show resistance to the S. pneumoniae strains. So we thought if our ligand can inhibit the transcription of this gene, then it won't release the known antibiotics, so we can enhance the antibiotic properties of the known antibiotics. So next we have studied N1 and other derivatives and their antibacterial properties. That is, we just simply determine the MIC values of these compounds on different strains. So we have taken bacterial strains like E. coli, A. pneumoniae, P. aeruginosa, B. cereus, and S. pneumoniae. And our results show that N1 that stabilized the PMRA quadruplex, which is present in the S. pneumoniae, show moderate antibacterial properties. So it doesn't completely kill the bacterial strain with high MIC values, but it has moderate antibacterial properties. So thus we thought, can we use these with the known antibiotics? So then we have studied the sensitivity of known antibiotics, that is, we have studied the MIC, determine the MIC value of known antibiotics. We can see many of these antibiotics which show very low MIC values, 4 or 8 microgram per ml. When we have studied against the patient-derived pathogenic strains, they already show resistance, like ciprofloxacin showing a very high resistance with a high MIC value. So thus we thought ciprofloxacin, which is released due to the drug efflux form, would be used as an effective model drug. So we have co-administered our ligand N1 with ciprofloxacin. And our agents show that when AN1 is added with ciprofloxacin, it could reduce the antibacterial, that is, it could enhance the antibacterial properties and reduce the MIC value, like 50 microgram per ml to 4 microgram per ml. So that means when we add AN1, so it enhances the antibacterial properties of ciprofloxacin by 12-fold. And this was further monitored by using qRT-PCR, that is, ciprofloxacin has no effect on the regulation of PMRA gene, but when it is combined with AN1 or AN1 alone to reduce the PMRA gene expression. And moreover, the AN1 is cell membrane permeable. It permeates the cell wall of S. pneumoniae, and we can see the blue fluorescence. So thus, I have shown that G quadruplexes can be targeted in cancer-causing genes like CE, and it can also be targeted in bacterial genome like S. pneumoniae. Like a ligand can bind and stabilize quadruplex, it can show moderate antibacterial properties, or it could enhance the effectiveness of known antibiotics. So, in addition to the targeting nucleic acid, where I have shown a brief outline of our research, we have also used self-assembly of DNA and RNA bases to make biomaterials that show like antibacterial and antimicrobial properties. And I have shown here one example where we have used a biomimetic template of hydrogel to promote the 1,3-dipolar cycloaddition. In addition, we use DNA and nucleobases to design artificial ion channels that can transport metal ions across the biological membranes. And moreover, we also develop new synthetic methods to synthesize natural products and biological active compounds. For instance, we have taken isatin as a building block and developed two different methods to synthesize carbazoles, and this method was used to synthesize a series of carbazole-based natural sugars. We also synthesize acridone-based alkaloids by using a simple synthetic method, and very recently we have shown that this dihydroquinazolinone can be synthesized by simply using base aldehyde and this amino nitriles, and the method could be extended for the synthesis of flucarpine, natural products and its analogs, and also benzomyl, another class of alkaloids, and all these compounds contain the dihydroquinazolinone core. And finally, as students, I would like to stop with a quote of Marie Curie, that is, the more you learn and understand, the braver and stronger you become. And I would like to thank all my past and present research colleagues for their hard work and cooperation, and funding agencies for financial support. And I would like to thank you all for your kind attention and patience. And I would like to invite all of you to visit ISS and visit the night view of our institute. Thank you.
Thank you, ma'am, for your wonderful lecture. Now, I want to receive some questions. Is there any question? Yes, ma'am.
Thank you, ma'am, for the nice talk. I wanted to ask you one question. Like, why this synthesized molecule only target the cancer cells, not the normal cells? Or what should be the basic approach of the molecule to target the cancer cells?
So when we synthesize molecules, we do not know actually which compounds would show selectivity for cancer cells or normal cells. So therefore, we have to identify targets, biological targets that are present only in cancer cells, that is abundant in cancer cells or highly present in cancer cells, but not in normal cells. So there you can target cancer cells by selectively targeting those biomacromolecular targets. And if we just blindly do that, it's difficult to find. Then we have to do a bigger screen to identify compounds which only kill cancer cells and not healthy cells. And then we have to also identify why as it now eat only cancer cells, what is the mechanism behind it? So that is that is the classical medicinal chemistry approach where you synthesize large number of compounds and identify a compound that kills cancer cells and not the healthy cells, and then you have to identify why, where it is targeting. So in our case, we have a target. We are identifying the targets which are present in bacteria or cancer cells which are not previously explored. And those targets, since we are putting here, we are sure that this will go to this target. Firstly, will have less undesired side effects.
Ma'am, actually, Professor Chittaranjan Sinha sir, he also came here physically, so he want to interact with you, ma'am.
So thank you, Professor Das, for seeing you virtually. Since our photobiology society is associated with this program and Dr. Paladhi and his principals has given us a chance, that's why I'm coming here. See, I have some small queries since you are doing the fantastic work, sir, you have that cancercinide compound in the last you have shown, as well as some carbazole derivatives. You know, this anthracinide shows some aggregation-induced emission along with the carbohydrates. They are aggregated in solution and forms some nano derivatives, nanomaterials. I think you have not checked their aggregation phases.
Now, we haven't checked because we are using very dilute conditions, and there we have seen the UV, so that is not making aggregation induced.
No, 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 no. Just you listen to me. In the dilute solution, they form the aggregation. Say solvent like PHA for reaction solution, and if you add dropwise water, then in the dilute solution, the molecules then aggregated with increasing the emission intensity. And in certain concentration of the say mixture of solvents, they exhibit the highest emission. So that I mean to say at which concentration level they are showing the maximum this antibacterial activity or anti-cancer activity, that may be an interesting area. This is one thing. And secondly, you have a lot of macrocytes. You have to join these macrocytes and starting their this biological activity. Have you seen what's the pH stability and thermal stability of these molecules?
They are quite stable, yes, they are quite stable. Because we have also made in gels, we have increased the temperature up to 80 degree, 90 degree, they are quite stable.
Okay, okay. Now, in different pH medium also. Since there are many imidazoles or imidazole or heterocyclic nitrogen, so they are usually being protonated or deprotonated by changing the pH. So that may also affect your activity pattern.
No, they are protonated, that's why they are binding because they contain amine side chains. So under physiological conditions of pH 7.4, they are protonated. Therefore, they are doing these electrostatic interactions with the negatively charged sugar phosphate backbone. That is how they are designed in that way.
Okay.
To become protonated and interact.
Okay. Thank you.
Ma'am, one more question from.
Thank you, ma'am. First of all, I would like to thank for your valuable lecture. The question is that in DNA double helical model, sugar-based phosphate, which are mainly present or found in the alternation of generation, that is sugar-based phosphate. But in therapeutic quadruplex structure, how it is exist?
I did not well understood your question. Can you little bit keep the mic far from your face?
Ma'am, first of all, in DNA double helical model, sugar-based, that is the nucleotide which exists in sugar-based phosphate. Sugar ribose petrosugar, base nitrogenous base like adenine, guanine, thymine, cytosine. But in case of quadruplex therapeutic structure, sugar-based phosphate arrangement is of which pattern or which type? Yeah. Yeah.
Can you see? You see sugar, phosphate, all are there.
Yeah. The second question is that in Australasia.
The three components are in, like you are seeing the chains that these are all sugar phosphate backbones, and these blue ones are only this guanosine. Okay.
Yeah.
It's the sugar phosphate backbone. And only the base, like you know, double helical DNA, what you are seeing the base, and this sugar phosphate is in the groups and loops. And here you are seeing only the bases are stacking upon each other. The same way, here you are seeing only bases, and these chains, what you are seeing is sugar phosphate backbone. And the same way here also, you are seeing the stacking interaction of the bases, G413, red, I motif, and this ribbon, what you are seeing is the sugar phosphate backbone. So that is there. This is the same way. The nucleotide, only one nucleotide adopts this structure. Like this.
Thank you, madam. The second question is that in Escherichia coli, E. coli, olive diplococcus pneumoniae, which is the causative agent of pneumonia in lungs, the double-stranded DNA is confined. But what is the reason behind it? It is present in quadruplex tetrahelical therapeutic, but not in viral diseases. Yeah. Ma'am.
This is also a piece of DNA. And they have also a complementary cytosine in this DNA sequence. But this is less abundant than the double helical DNA. Yes, pneumonia has also double helical DNA, but in the virulence causing genes, only 3 quadruplex structures are present in S. pneumonia. So therefore, it is easy to target the 3 quadruplex than the double helical DNA. Okay, so here only this is computational study that only these 3 quadruplex forming sequence are present in the virulence causing. So there are 3 virulence causing genes, HSDS, RED, and PMRA. So these genes contain in the like this G quadruplex forming sequences. And you see this is GGG. If there are 4 stretches of G and 3 Gs, 12 Gs you need for making a quadruplex structure. Okay. So then this and the remaining are in the loop and groove region. So this also pneumonia also contains duplex DNA, but we are targeting the quadruplexes.
Thank you, ma'am. The last question, my last question is that in a ciprofloxacin antibiotic, we use a 50 MIC, that is a microgram per ml square, but it is not validated in azithromycin in the case of children. It is approximately 250 ml to for children. What is the reason behind it, ma'am?
Actually, ciprofloxacin has a less, like 4 microgram per ml. But when we have got the patient-derived pathogenic strains, it has already shown resistance. It has already the MIC value is increased.
Thank you, ma'am. A lot of thanks.
That is just feeding the bacteria, but the dose is different.
Thank you, ma'am. Thank you. A lot of thanks, ma'am.
Thank you, ma'am, and thank you for giving us time in this short piece. And thank you. Thank you. Bye. So with this lecture, we will end up the online session and we will start the offline session. And first, we will have Professor Chittaranjan Sinha, who will deliver the first lecture After that, we will continue the faculty presentation here. Okay. So, first of uh, now, next offline speaker, we have with us Professor Chittaranjan Sinha, who is a professor in Jadavpur University, and he is also the secretary of Indian Photobiology Society. So he is with us today. Dr. Chittaranjan Sinha did his MSc and PhD and former head. He is former head of Department of Chemistry of Jadavpur University. He was also ex-dean of the Faculty of Science of Jadavpur University. He is a renowned researcher in the field of chemosensor and ion molecule detection with over 510 internationally cited publications, 9,900 plus citation and H index of 50 and I10 index is 278. His profile contribution to chemistry are globally recognized. He has authored more than 15 book chapters and participated in over 200 national and international seminars. Dr. Sinha has consistently listed among the top 2% scientists worldwide by Stanford University and Elsevier 2020 to 2024. His accolades include the International Lecture Award from Padova University, the Best Chemistry Teacher Award by Tata Chemical in collaboration with ACT and C2, and the William Ramsay Distinguished Research Award 2022. He is an elected fellow of the Royal Society of Chemistry, West Bengal Academy of Science and Technology, and Engineered Science, with supervision of 55 PhD scholars, 80 plus master's theses, and leadership is 20 government-funded research projects. Dr. Sinha has made lasting impacts in both research and education. He has held key editorial roles in several journals, served as honorary secretary of Indian Chemical Society. So I will continue. I just want to introduce that which chemical society you are seeing today. Actually, it is for him the chemical society established in this position, and now he hand over this to other respected members. Actually, so he beyond academia, he actively promotes science education, supports underprivileged students, and runs a school under blessing of the Ramakrishna Mission in his native village. So, with this short introduction, I now request Professor Sinha to start his lecture.
Namaste. Thank you, Dr. Paladi, and thank you all for giving me this chance as well as my society, Indian Biology Society. And there are robots of Jadavpur University as well as and there's a logo of this college, Prashant Singh, and it belongs to the jurisdiction of Patna University. I belong to the Jadavpur University, and this logo is to the Photobiology Society. I am also the chief editor of a journal published by the Engineer Science, which is ES Chemistry and Sustainability. All this is an open access journal, but now till February 26, it remains free to publish. If you have any research paper or review paper in the field of this particular field of chemistry and sustainability, so you can send to this journal, which may be considered for publication. No fee is necessary. Today, this is my pranam to Lord Buddha, the place of Padaliputra. You know, one of the pilgrim of the science technology in the ancient times, Nalanda, Padaliputra, all these things. Today I am talking about this. My topic already told you is sustainable development goal. Sustainable development goal. This idea was first included by UNDP in 2015. What is that? Sustainable Development Goal. That means for the future generation, this art, only art, has to survive. What we are doing today, I observe, with reference to the Kolkata and your Rajendra Nagar, I could not find the plants. पेड़ नहीं है आपका शहर में Even बच्चा पेड़ भी नहीं है. You are expanding your city. You are building up big bridges as well as the big buildings, but you are losing our environment. So, the sustainable development goal for the survival of our future, our children, for their better earth, you have to bring peace in your city. Otherwise, very difficult for in future. There are few points, in sustainable goals, there are 17 important points took out by the UNDP, and their target is known as the Agenda 2030. That means within 2030, carbon emission in the environment will be reduced by 50%. And Government of India, also a partner of this signatory authority of this goal. And by 2075, all the fossil fuels journey will be stopped and all the fossil fuels will be replaced by our non-carbon fuels like hydrogen fuel. And by 2030, government has decided, particularly in the mega city, the transport will be replaced by CNG along with the non-carbon fuels. See, one of the important part, since we belong to chemistry, our life is chemistry. If you go to the periodic table, out of 94 naturally occurring elements, 27 or 28 elements constitute our life, and out of them, 11 elements they are in bulk amount, and the rest are in the trace and alternation. And they are increase in concentration means the increase in concentration of the nutrients that is defined to the increase in the rate of the relative yield of the rate of the biological reactions. But with increasing this concentration, for example, our blood contains iron. Without iron, blood cannot work its activity. But if you continue iron consumption, those are suffering from anemia. They are the one important drug is the ferrous sulfate. Only ferrous sulfate. That will give you the iron in blood. But if you increase the consumption of iron, what will be the fate? All we are in the all film Ganges belt from Gangotri to Gosawar. This Ganges belt under the area of the iron containing. And our underground water has huge amount of iron both in New York area as well as in Kolkata area. So if you increase this iron content in biology, what will happen? Although it requires, but it has certain limits. By increasing the amount of iron in blood, certain information will come to the biology, so the toxicity generates. So you cannot consume. So that's why a plate region comes, and after increasing this concentration, the toxicity generates. But the madam told you the anti-cancer agent, the drugs are also toxic at certain concentration levels. That's why he's talking about the MIC health, minimum inhibitory concentration. Okay, let's go to the Sustainable Development Goal. UNDP has published this. You see this fire. In this fire, you see every minute we are using 23 hectares of our forest. Every minute. Every year we are losing 13 million hectares of forest. And also, the world is losing precious biodiversity at an alarming rate. And these are because of the deforestation, expanding our civilization, and so on. So that the water, out of the total water content on Earth, only 3% surface water is available for our living purpose. See, out of the 1% on the surface water, that means river, ponds, as well as underground water, they are the only 1%. Out of this 1%, 70% water is consumed by the agriculture. 23 to 24% water is consumed by your thermal industry, as well as steel industry, thermal industry, coal industry, and so on. Only 3% of out of this 1% of the total water we are consuming for our living. And for this water will make a big crisis in the globe. And what if third world war comes at all, then it will come because of water crisis. And this water, there are many cities in our, not only cities, rural India. See, if you go to the western part of the country, Gujarat, Rajasthan, the drought area, and the underground water contains huge amount of chloride. In the Ganges Valley, from Gangotri to Gangavasar, you and me also, in Kolkata as well as in Bihar, Patna, Rajendra Nagar, the underground water contains significant amount of arsenic at this Ganges Valley area. So all these are responsible for our problem. And in this periodic table, you can see all these color elements, they constitute our life. Yeah. And these elements out of them, traditional system of medicines is Ayush, Ayurveda, Unani, Siddha, Homeopath, all these contains the Ayush. We have also Government of India has a department, as a ministry of Ayush. And all these are the natural products that is responsible for our growth as well as longevity of life. And these different metal ions have the different roles in our biology. Sodium, potassium, in the old age, there is a problem of sodium potassium ratio, and that causes the dementia as well as certain types of Parkinson's, Alzheimer's, and so on. And then it regulates the impulse across the cell membrane, calcium, magnesium, some nerve regulation, and so on. So there are all these metal ions have a definite role in biology. Not going to the detail of it in our chemistry laboratory, we are practicing this the hard water or soft water. Our undergraduate students are doing that experiment to talk about this hard water, soft water problem and also the titration. And one of the important part is the heavy metals. Heavy metals is mercury, cadmium, lead, arsenic, etc. They belong to heavy metals. Who are the heavy metals? If you ask your students who are the heavy metals, define it, nobody will define it. Nobody can define the properly who are the heavy metals. In the periodic table, those are the elements having atomic number greater than 30, or those have the density 5 gram per cc or greater than that, they are the heavy metals. These heavy metals, what just madam told you, the DNA structure. There are the amino acids along with the DNA bases, adenine ATGC. These ATGC, they are hydrogen bonded, and they are the hydrogen bonds of the information store and the transfer to the protein. These hydrogen bonds having the purine nitrogen, heterocyclic purine nitrogen, imidazole nitrogen. These nitrogen can bind to these metals. Because of the binding information storage or information transfer towards the next protein will be difficult and causes the disease. So heavy metals are coming in our biology in different way. One of them is the cigarette smoking or quinine, tobacco. Those who are consuming this tobacco, quinine or cigarette, they are the tobacco leaves. This tobacco leaves to increase the longevity of the burning period of tobacco leaves in cigarette. See, if one cigarette is burned at 5 minutes and another cigarette of same length burned at 15 minutes, what will be the favored by the smoker? Certainly second one. Why second one is increasing its burning time? Because of this cadmium. Since the tobacco leaves are dipped into the cadmium acetate solution and then dried up, and that cadmium, that tobacco leaves is used to make that cigarette. So the cadmium is coming into biology, and thus cadmium causes varieties of toxicity, and along with the arsenic. These are because we have many sulfide protein in our biology. Glutathione, reductates, cysteine, all sorts of sulfide proteins, and these are the agents or the reducing centers to meticulously participate in the redox reactions in biology. These sulfide centers are blocked by the heavy metals because of the SH principle. This SH then bind with mercury or cadmium or lead or arsenic and will block the function of the enzymes and proteins, thus the biological activity will be stopped. Arsenic toxicity, all sorts of skin cancer and some other anemic problem of arsenic causes. And this arsenic situation in West Bengal is this one. From Darjeeling to 24 Pargana, the Bay of Bengal, the red zone you see where the arsenic content in groundwater is more than 50 microgram per liter. 0.1 microgram per liter is the WHO recommended tolerance limit. So it is 500 times higher, the red zone. And also yellow zone, where the mercury arsenic content is around 3 to 50 microgram. And only the green zone where this water is only available for our general purpose. And fluoride toxicity, those who are using the toothpaste, that is fluoride content in toothpaste for the children commonly used, but avoid it. Since fluoride causes the toxicity in biology and the brittle bone disease, and the phosphate and nitrite, they are coming from the fertilizers. Huge amount of fertilizers, phosphate fertilizer, as well as nitrite fertilizer, urea is used for their activity. Eutrophication, that is the algal blooming in water because of this phosphate. Since phosphate is a energy rich ion, ADP to ATP, that's the energy on this phosphate is responsible for the bacterial growth as well as for algal blooming in water that reduces the oxygen concentration in water. And this is the reason for the problems of the water bodies. So this is my Kolkata municipality area, for the arsenic toxicity. And this is for the aluminium. And the aluminium toxicity, aluminium beads and aluminium foils are used for the carrying over the food materials. Since that's aluminium coming quickly from the aluminium pieces or utensils, if you put your tomato sauce on aluminium bead, since aluminium beads quickly, since tomato sauce having pH around 4.5 to 5, at that pH aluminium comes in biology, and this aluminium deposits in drains, which causes, as such aluminium does not have any beneficial role or this beneficial role. But the aluminium at pH 7.4 of the blood pH, aluminium started to precipitate as aluminium hydroxide, aluminium phosphate at pH 5.5. So at 7.4 it is precipitated and blocks the neurosignal. That is the reason for the Alzheimer's or the Parkinson's. So aluminium toxicity. Similarly, zinc is known as the mother of metal enzymes. More than 300 metalloproteins and metal enzymes are running by the zinc. But this zinc in excess also very toxic. India is a country, ancient India, who first extracted zinc in the globe. And India is a country who second in the extraction of iron in ancient time. And we are the first who extracted the security of the alcohol or the rosso. That is the rosso chemistry is the rosso Rosayana. So rosso means the elixir of life, that is the alcohol, first fermented by the Indians. Okay, this is all about the ions or the elements, those are concerning our biology. So they are increasing concentration or decreasing concentration, both are harmful for our health, our origination, our growth, development, survival, as well as death. Everything is responsible for these elements. And these elements in the form of the ions or the molecules present in our biology, they have been detected by the two different ways. One is the electrochemical pathway, other is the spectrophotometric pathway. In the spectrophotometric pathway, we are commonly adopting the fluorescence spectroscopy. In the fluorescence spectroscopy, the ions or the molecules, those have been sensed by the sensor, those are known as the chemosensor. This is one of the carbon picture. So this is a sensor which can bind the analyte and this fluorescence intensity is enhanced or can be quenched, for that it can be determined. So there are many techniques for the mechanistic part of the fluorescence technology. Not going to the detail of it. And rather, we are coming to the point that in our laboratory we are synthesizing different types of molecules to detect that all the ions. You see, here is the color is like this. You see the green emission. And two different vials are present for vials. In one vial, only this molecule is present. And in another vial, we add the zinc ion. Then immediately zinc shows the green fluorescence. From this fluorescence measurement, we can immediately determine the presence of zinc. And around 15 nanomolar concentration of zinc can be determined. Nanomolar, you see, zinc 50 into 10 to the power minus 9 molar concentration can be detected. And this one also, different metal ions are also used. Here you can see the fluorescence intensity is enhanced only in presence of zinc ion, while all other ions do not give you any emission enhancement. And this one, the molecule upon zinc, this green emission, if you add different anions, then only in presence of dihydrogen phosphate, H2PO4 minus, the its emission is quenched. So this molecule acting as a dual functional system, at one hand it can detect zinc, on the other hand it can detect the dihydrogen phosphate, and that detection can also be done in the cell. You see, in this cell, where this molecule is added, but there is no emission. As soon as zinc is added, that green emission comes. So the presence of zinc concentration in cell can also be measured. And also, uh, there are some of the slides and are looking. There is another molecule. This molecule this is another molecule. This molecule is responsible for aluminium sensing. I already told you the aluminium toxicity. In the food or beverages where the aluminium present, you can easily detect by this enhancement of emission intensity. And this aluminium sensor can be used to detect the fluoride. I told you the fluoride, which is in the underground water in the Rajasthan as well as in Gujarat, is a trivial problem. Rajasthan, Gujarat, Maharashtra. There's a trivial problem of fluoride toxicity, brittle bone disease, and this fluoride can be detected by using this molecule which shows the blue emission. This emission is quenched. See, we added the huge large number of anions, but their emission intensity does not show significant change. Only addition of fluoride, the emission intensity has changed. Hey, something is problem in here. Where is Palad? They are not seen. Even we design another molecule, you see, this is a rhodamine-based molecule. Majority of the organic chemists, which are synthetic organic chemists, they use palladium as a catalyst. Palladium charcoal catalyst, or the palladium 2 compounds as a catalyst, palladium 4 compounds as a catalyst for their organisms. Even the drugs, the palladium received the Nobel Prize also for their application in the organic synthesis. And for the drugs or the food products, they are also, or the nutrition products also synthesized by palladium catalyzed reactions. But do you know the concentration of palladium which is coming leached into the product? The organic chemists, those are synthesizing it, they can't answer. Or even it's very difficult to detect the concentration of palladium 2 or palladium 0 or palladium 4 in the product. Since it is in the nanomolar concentration of palladium is highly toxic. Although platinum is anti-cancer, a broad spectrum anti-cancer, but palladium is highly toxic. But for the very small concentration, little concentration of palladium in the product becomes toxic. So we designed a molecule. Here is this rhodamine-based molecules. You see, this molecule does not have any absorption or light yellow, but addition of palladium, it shows as a beautiful absorption as well as color, and in the fluorescence spectra you see our ligand or organic molecule which we define as a sensor does not have any emission, but on adding palladium only it shows a strong emission. And the different types of cations are used, lot of cations, more than 20 cations are added, including platinum, but it does not show emission, while in case of the palladium only. So we detected palladium, you see, the detection limit is only 18.8 nanomolar. 18.8 into 10 to the power minus 9 molar concentration of palladium can be detected. And even the cell, but the cell you see, in the cell the presence of palladium is detected by in this way. So these are the different molecules. One of them, one of the hydrogen-based thiocarbamide, this molecule is designed. And this molecule is interestingly arsenide sensor and phosphate sensor. Out of arsenic 3 and arsenic 5, arsenic 3 is deadly toxic. And it is cancerous also. So arsenic 3 detection is a trivial one. So we find that this molecule detects arsenic by fluorescence microscope. Even another molecule will design which detects the phosphate as well as citrate. Both phosphate and citrate they are the energy giants, and they are also be detected in cells by using simple molecules. In case of anions, cyanide is one of the important anions. Those who are the smoker, constant smoker, their blood has very high concentration of cyanide, commonly thiocyanide. Cyanide is a deadly toxic anion, and it is known to us. And cyanide is available in many fruits, as like apple. Apple has significant amount of cyanide, as well as many spinach has also cyanide. And this cyanide, those who are consuming cigarette, you know what the temperature at the burning point of cigarette wick? It is around 700 to 800 degrees centigrade. At this temperature, tobacco organic materials, they are oxidized partly, not fully. And part oxidation generates carbon monoxide and cyanogen gases. More than 400 chemicals are generated during the burning of a cigarette wick. And out of them, 40 are highly toxic. And cyanogen is one of them. But the biology has generated a system that is the defense mechanism. The cyanide, those are coming to biology. This sulfhydryl enzyme, this glutathione reductase of cysteine, etc., they make it to thiocyanide, HCN minus. CN minus is toxic, but HCN minus not toxic. This is biology is doing. But increase in concentration of cyanide regularly in biology will cause varieties of problems. So cyanide can be detected very easily in the biology also. Our molecule is very simple molecule. You see, lot of anions we have added. No change in the color of our compound. While upon addition of cyanide, it goes to yellow. Very simply, we design some paper strip and leaving that paper strip when it turns to color yellow, we can detect that even the concentration. We have the standardized way to measure it. Okay, another series of molecules we designed. These molecules are responsible to synthesize coordination polymer or metal organic framework. A very interesting area of research now. Those are working in the interfacial research in the field of biology, chemistry, as well as catalysis. This field of metal organic framework is one of them. Metal organic framework, that is the metal coordination polymers, there is some cavity like zeolite. You know, zeolite in the community, they absorb the different cations to filter out our water. The water from the surface is gradually recharging process continues by filtering through zeolite. Zeolite has a cavity where the ions are captured. Similarly, metal organic framework has the cavity. Herein that this metal complex having this cavity is very selective one, but madam also shown you the macrocycle. This macrocycle has a cavity which interacts with the G for protein. Similarly, this cavity can interact with the metal ions, anions as well as molecules. Here in this cavity interacts with the dihydrogen phosphate and the emission intensity of this molecule is being quenched. Thus, the dihydrogen phosphate can be detected even in the cells, you see. We have also designed similar types of molecules. This is another molecule of cadmium base. This molecule is not only detect this ion, but it detects the explosive compounds, nitro compounds, nitrogen-rich compounds, nitroglycerin, TNP, DNP. They are the explosive materials. These explosive materials are being detected by our material. Well, what we have? There is also cavity. You see this cavity. This cavity absorbs selectively this explosive TNP and detects its concentration. There is another one. This is also a coordination polymer with this predyl naphthyl derivative. This molecule can detect chromium. The chromium, you know, chromium 3 plus has a weak electronic configuration. Commonly paramagnetic ions are coincident. But here in chromium in that stage, absorbing chromium its intensity, fluorescence intensity is generated. So that diversity is found in our material. And also herein also we design another molecule. This molecule, you see, there are varieties of cations are added. Only in case of copper ion, the yellow color is quenched. So it becomes a copper sensor. So copper ion, even in the cell, this copper ion concentration is also detected by our using these molecules. Here we design another material. This material is made up of zinc, zinc metal organic framework. This zinc framework detects iron to iron 3. Iron to iron 3 in water is very important for health as well as for everything. So the iron concentration in water, drinking water as well as beverage is very important. You know, our material can easily detect iron to iron 3, but we cannot segregate whether what is the concentration of iron 2 or what is the concentration of iron 3. Total iron is detected. But another material we have designed, here you can see, this is a copper molecule, this molecule is very selective for iron 3 only. It determines only iron 3. So by using these two, we can detect iron 2 and iron 3 simultaneously. Having a copper complex, this copper complex, this copper complex is very interesting one, because this copper complex can detect tryptophan, tryptophan and melatonin. You know, tryptophan and amino acid, and melatonin and neurotransmitter. They have versatile use in the biology. And this tryptophan, melatonin, they are detection very difficult and very low concentration. Ultra low concentration detection is very important. Since they are increasing concentration or decreasing concentration is unable to violate. So our molecule detects this molecule, and this molecule detects both tryptophan as well as melatonin under different conditions. You see? There is another molecule. This molecule also a cadmium-based molecule. This molecule also detects trinitrophenol and explosive material. This explosive material, its concentration, increase in concentration, fluorescence intensity is which from that data we detect their concentration also. Not going to the detail of it, here is you see another gene complex of the similar type molecule. This molecule is useful for also the detection of trinitrophenol. Along with this molecule is useful for the aluminium measurement and the recycling of this material for the aluminium detection. And you see the aluminium detection limit is 1.39 into 10 to the minus 7 molar, while TNP sensing limit is 1.54 into 10 to the minus 7 molar. And also there is another molecule of cadmium. This cadmium 2, this molecule is very useful for the detection of also TNP, trinitrophenol, and also in the zinc complex in the cells. Okay. Here you see another interesting molecule which is also cadmium based. This molecule, you see the color. Here you see the color. The color change is very interesting one, and this color change is observed for this particular measuring the concentration of iron 3, and this limit of detection you see 84.6 nanomolar and absolute thickness. And the mechanistic aspect of the reaction, etc., we have detected, and also interestingly, there is another molecule, naphthyl-based derivative, naphthyl-based pyridylamide. This molecule undergoes the aggregation, and at this particular aggregation concentration, it shows the highest emission intensity. And this molecule is very interestingly sends the trifluoroacetic acid. You know the trifluoroacetic acid is a volatile acid. They added into for the preservation of different types of food. In the food industry, they use this trifluoroacetic acid. This trifluoroacetic acid is corrosive, so they are very unhealthy also. So their detection also be made. You see, the fluid square is the presence of trifluoroacetic acid. Okay. There is one of another molecule. This molecule shows very interestingly the microbial feature. Microbial, our madam also told you the relation. This material also shows some their feature. And this daily life substance, they are also useful for the detection of cyanide. Here you see the series of detection of the anions, only in case of the cyanide, a violet color is observed. So cyanide detection by using the using this microbial is very useful for our chemistry. Okay, not going to the detail of it, I have to summarize everything. We have designed some nanoparticles. Silver nanoparticles are synthesized by using some plant extracts. One of them, you know, the oxygenase curricula, which is a particulata, which is known as the amru, locally amru. That spinach we use for our different types of sauce preparation. And this is used for the synthesis of silver nanoparticle, biogenic synthesis as well as stabilized by heat. And this is very useful antibacterial agent. And this antibacterial activity, the mechanistic aspect is observed. E. coli, you see, the commonly this bacteria cell is you see the very smooth. While on adding our silver nanoparticles and this bacterial cell one split, that it acts as antibacterial agent. And also another one, to prepare one nanoparticle of silver nanoparticle using the garlic extract. Garlic contains the several types of sulfur compounds. The sulfur compounds reduces silver 1 to silver 0. This silver nanoparticle then it is mixed with the metformin. You know metformin, those are commonly diabetics, they consume metformin in different amounts for the control glucose concentration in blood. And we prepare this molecule, this material, that is the nanoparticle with metformin. Then it acts fantastically. It acts as antibacterial, anti-diabetic, and also anti-cancer. Very interesting one. And regarding extra and its mechanistic aspect also observed by measuring the same images and also silver nanoparticles entered into the cell, that are observed by this series of activity. Okay, not going to the details, this is the summary one. For the sustainable development goal, our objective is to detect the ions of the molecules, both the toxic ones and the concentration, very low concentration in solution. This is number one. And the different ions we have observed throughout, as well as their biological activity. And secondly, designing part, we design the molecules as well as theirs and also metal frame. Out of the metal framework is the best one, since it is sustainable, it can be reused, recycled, recovered. And these metal ions are removed and not biodegradable, as well as toxic like cadmium, but in the metal organic framework, they remain as it is. So this is one of the advantages. And other one, the nanoparticles are prepared by using the hydrogen groups or the biogenic groups. So these nanoparticles does not have any chemical component for their preparation and sterilization. So and they are unique in a sustainable manner as well as an interfacial manner for their utility and anti-cancer, antibacterial as well as anti. So thank you for your kind attention, for giving me this chance. This is my university, Yadavpur University, who the VC Aurobindo, who was the rector, and Yadavpur University, only university in the country that is coming to the national movement. That is our freedom movement. When in 1905, Lord Carson divided Lahore. In 1906, the freedom fighters in Kolkata, they joined in a meeting and then constituted National Council of Education. National Council of Education started the National School Policy. With this National School idea, mooted by Acharya Prabhu Chandra Rai, father of Indian chemistry, and Madan Mohan Malviya then started the BAU. Periyar Swami started the Periyar University in South. So that throughout the India, the concept of national school, the national school, Acharya Prabhu Chandra Rai was the secretary and Netaji Subhash Chandra Bose was the president. So student and teacher, Subhash Bose was the student of Prabhu Chandra Rai of the presidency college. So student is the president and teacher was the secretary. With them, idea the national school, the National Council of Education started. And then they started one engineering college known as the Bengal Technical Institute. We said that to train our members of country so that they will start their activity, particularly the skill development. Today, the government of India started school development program. National Council of Education through Bengal Technical Institute started first time that our farmers have to be trained how to prepare their farming processes. These are the idea at that time. And that time this Bengal Technical Institute, after the independence in free India, that is turned to Jadavpur University. And Jadavpur University is the number one university in the country and received the national award from the state run, out of state run university, more than 1200 state run universities in our country. Out of them, Jadavpur University is number one. So thank you. They are my students who will be in the different fields, and very few of them are working in this sensing area. And I am from the Indian Photobiology Society. Before leaving this platform, I will just tell you the story. And you see, this lady Krishna Kamini Ruhati Mukherjee. And the fundamentals of photochemistry, she wrote a book, textbook, Fundamentals of Photochemistry, published by New Age Publishers. And most of the students, those are in physical chemistry. And now it is the photochemistry is not comes to physical chemistry alone. It is both in organic, inorganic, physical, biology, as well as physics. So this is the number one only textbook first published in India by an Indian author. And she started this Indian Photobiology Society in 1964, then in 1970. And the photobiology research was started in the country by one of the illustrious scientists, the student of Acharya Gopal Rai, A. Dhor. Nilrakon, who was the torch-bearer of chemistry in the northern part of the India, he started the Allahabad University, and his research was to find out the mechanism of nitrogen fixation in soil. You know, that time he started the nitrogen fixation and this mechanism. And his name was forwarded twice for the Nobel Prize. And S.S. Bhatnagar, you know, S.S. Bhatnagar claimed himself as a grand student of Acharya Gopal Chandra. Since his teacher, Atul Chandra Bose in Lahore College, was the student of Acharya Gopal. And also J.C. Bose, Gyanchandra Bose, who was the first director of the first IIT of the country, IIT Kharagpur. Then he was the director of IIC. Then he became the vice chancellor of Calcutta University. He was the photo gang of Acharya Gyanchandra Bose, and who published his first paper working with Acharya Rai during his MSc project in American Chemical Society. And Baba Kartar Singh was the first photo-organic chemist in the country. And then L.B. George, first photophysical chemist in the country. Along with Mihir Chaudhary, Kaman Bhattacharya, and the former president of Nitin Chattopadhyay, and now president is Ashok Mishra, the professor of chemistry in IIT Madras. And thus our program is running in different way. This is the membership forms. And you know, we are organizing monthly science talk. Every month, commonly last Saturday of every month in the evening, virtually organize it. This month, tomorrow will be the programs because of the 27th September, the Sosti Durga Puja. Because of that, there is this free on the 20th. Tomorrow evening, the talk will be given by the Gauri Shankar Bose, who is a professor in University of California, San Diego. He will talk on the tracing the source of neurological disease. And second one, the Ujjwal Pal. Ujjwal Pal is a scientist in IICT Hyderabad. He will talk about rise of solar drive with green hydrogen. This is land innovation reality. So you can join in our meeting through this Google link without any fees. Anybody can join. So we generally invite one or two university or colleges as a collaborator. This time we have the two collaborators. One is the PG college in Medinipur district, Midnapur College, Department of Chemistry, and another one is the SKB University, Sidhu Kanu Birsa University in district Purulia University. So you can join. And another one, our annual convention of Indian Photobiology Society will be held in IIT Dhanbad on 1st and 2nd December. We will circulate, it will be available in the website of the IIT Dhanbad as well as of the website of the ITS, so this will be available. You can join that. This is an international seminar. Many illustrious interdisciplinary scientists will be joining this program from different countries. And the funding for the research comes from the different sources. And also, my pronoun to our great teacher, great friend, and the two country of Acharya Gopal. Thank you for giving this chance. I welcome you all to join the society. Only 4,500 rupees for the live members. So thank you. if you have any queries.
Yes, I'm having. Pranam sir, thanks a lot for your fascinating lecture. Otherwise, either two I had been thinking that when we would be having a sort of fascinating lecture from chemistry. Sir, I'm having two queries. Two queries. First one is that you have been talking about Rasa Shastra. I mean the science Shastra. Okay, sir. Sir, here I just wanted to know whether the rust which you told us it was about alcohol. Was it green tea or something kadha like that, or a chemical drink, or simply alcohol, sir?
No. I am not talking about this one. Rather, I am talking about the Rasa Shastra. If you go to a history of Hindu chemistry in Vyasa, because of this term Hindu, he was being stamped communal during that period, even today. But he told that Hindu is not a religion. Hindu is the philosophy. Hindu is the culture. Those are living on the bank of river Sindhu. So therein he clarified it. Since Rasayana, it is coming from the Greek word chem. And in our country, in ancient India, if you go through the alchemist and even the Nalanda and in the Nagarjuna, who was the last vice chancellor of Nalanda University, in the time he was the 10th vice chancellor, he wrote three, four books. Rasaratna, Amitra, Rasaranabhav, Rasaratna. On all these books, they belong to the iatrochemistry. Iatrochemistry means chemistry of metal oxides. Metal oxide bhasha, they are the medicines. Sarna bhasha, Arad bhasha, Tamra bhasha, they are the medicines. And there are two objectives of the alchemist. One is the transformation of iron to gold. This is symbolic, not iron. Iron is the most useful material, while gold is the most precious one. Today, the material science, material chemistry, or the sustainability, this is also part of that. Although iron to gold and nuclear transformation or transmutation, they are not winning this much. Rather, they use iron and sulfur, fuse it, and make a very beautiful golden color compound which looks like gold. That's why iron to gold transformation does. And second one is the elixir of life. Elixir of life means that some extracts from the plants or from animals. Those are very useful for our life. And also comes from the gold science or from the mercury science or from the silver science. And nobody knows from where it comes. Like Rosho means Amrita. Amrita, that comes from, there are stories, there are many stories of that. So Amrita, which is responsible for elongate our life as well as youthfulness. So Rasa Shastra means elongate our life. So this is the part of the science. So the alcohol extracted by the Indians first was through fermentation process, and for the the Ayurvedic medicines or the homeopathic medicines that solvent is the alcohol. It does not mean alcohol is healthy. See, alcohol, all the food particles, carbohydrates in our biology, is also transformed to alcohol, since alcohols are easily absorbed by the cell and can give you the energy immediately. And that is the reason that elongates us. It does not mean if you consume alcohol, thanks to Bihar government. Why, if you go to India or Kolkata, this, you can't imagine what is happening there. Few days back, one of our students who died and drowned in a very water in campus also. Because of she was fully planned. And undergraduate student, there was a program in the evening, program by a drama club in the campus. She took alcohol also. That was she is going to the bathroom, and there is a pond, and she took not identify whether it is pond or the road. Now the investigation is there. Thank you.
Genuinely thankful to you for the answer and so many related things also which enlightened us. So our second query is
that when you have been talking about aluminium toxicity, you have been talking about that 7 to 7.5 at pH scale. Tomato sauce could be dangerous if it is put in the container aluminium. So then not to talk of these canned soft drinks because the container is of aluminium and pH scale is more less than the tomato sauce. So we should avoid it. Should we make a sort of movement for that? Should we pressurize the government to ban these products because ultimately there will be a problem of Parkinson's disease and dementia? Yes, the problem is that we are saying tobacco is carcinogenic, but we are consuming it. Yes, yes. Yes, sir. Thanks, sir.
If you take us to inactive, you do continuously drink that softness. Since its pH is even less than 2, our stomach pH is what? Stomach pH is the one normal HCl pH. And our bile pH is around pH 12. So different biological bioorganisms have the different pH. Sweat pH, sweating, its pH is around 5.5. While our tiring, it has also pH with low pH, so the acidic pH. So biology has the different zones with the different pH. So it is not healthy at all for the consuming softness.
First of all, I would like to thank for facilitating such types of seminars. First of all, I heartily welcome you, sir. There are some questions, but first of all, I want to interrupt you. I was the indigenous system of medicine is basically known as Ayurveda. You know, tobacco, sometimes you are talking about tobacco, the polycyclic hydrocarbon that is called lar or tar. In China, the death rate is very high for cigarette smoking. In our India, one cigarette smoking is more dangerous in spite of drinking one bottle of alcohol. It is not my report, it is the report of World Health Organization. Sir, you were talking about SDG, Sustainable Development Goals. There are 17 goals conceived or forwarded by UNDP, United Nations Development Program. Sir, there are some questions. First of all, ADP combines inorganic phosphate in presence of 7.6 kilocalories to form ATP. Usage algal bloom that is called pond escom, aluminum foil toxicity, gene coating materials. We eat apples. In the seed of apple cyanide found, we brush with our teeth, sharp teeth. One who discovered hydrogen cyanide, it is proverb, I don't know. He died. The question is that, then what is the determination for the sustainable goals? There are 17 goals. How we can achieve the goals of sustainability? We use hazardous substances, chemical substances, death rate is also very high. And one side we said to achieve the sustainability. How can we achieve such types of 17 goals? We use explosives, we use different types of toxic chemicals, we use different types of toxic substances. One side we call in our power-based land in the era of 6th or 8th century. So, no sir, my question is that what is the toxicity? What is this toxicity in the reference of sustainable development goals? How we achieve the goals? We use different types of chemicals or hazardous substances, but one side we talk about the achievement of sustainability. On one side, we use different types of hazardous substances. Then how can we achieve sustainability? That is my question, sir.
See, this is coming in the school level also. 3R or 4R principle. Recycle, reuse, recover. Right? So, sustainability is referring to all these things. Since I am not sure what is your question. That sustainability in my initiation of the talk, I told you, in the Rajendra Nagar, which is the name of the Dr. Babu Rajendra Prasad. If you go to Kolkata, in the hostel, Hindu hostel is the hostel of Presidency College, now is university. There is one place of stone where it is written Dr. Babu Rajendra Prasad, first President of India, student of Presidency College, staying in this group. You know, so I have a deep respect to Babu Rajendra Prasad. On the 70th birth anniversary of Acharya Prafulla Chandra Rai, where Kobiguru Rabindranath was the president and Dr. Babu Rajendra Prasad, student of Acharya Prafulla Chandra Rai, was one of the speakers. Right? So that's why I'm surprised to see on the bank of the Ganga, the Rajendra Nagar does not have enough trees. So this is the first part. To tackle your environment, you have to move the plants on the street side, or you have to develop the social forestry. This is number one. Even in Kolkata, although there are only 4% of the roads, there are huge jams because of we don't have roads. Still, we have the significant amount of the green plants. Your first task for the sustainability is the plantation. That is number one. And from your practice, you are a chemist, I think. So if you are being a chemist, from your chemistry teaching and learning process, you have to motivate your students, friends, colleagues to follow the principles of sustainability. And we, the chemistry, have the different zones in the 17 points of the sustainability. One is the land and its protection, other is the water pollution, as well as the plastic pollution. One of the important parts, reusability of the plastics. So single-use plastic we have to ban. Single-use plastic, those are the less than 5 micron, you have to stop. Deliberately, the government of India cannot do it. It is you, me, and everybody. We can do it. Unless this consciousness comes, it cannot be done. This is the only way.
Thank you, sir, for your nice. I have two queries, and both queries are somewhere or somehow interconnected. During the talk, you have some mentioned the palladium flow. So, in that palladium flow, usually used as a catalyst because palladium is high oxidation state. 0 and 2 is more prevalent. It is very scattered related. But palladium flow. And the second query is related to why only the palladium. Other two partners in the same group, nickel and platinum, usually not use that much as was prevalent is palladium used as a catalyst.
Thank you for it. Palladium oxide is used. PDO. PDO2 is available. Palladium oxide is charcoal. That is also used as catalyst. And this is very uncommon, but there are palladium 4 is found in situ generated during the catalytic. Yes, that's why palladium 4 is. We have also designed a molecule which detects all palladiums, total palladium, 0, 2, and 4. No, even some of the referee have asked me for predicting knowledge. Yeah, this is. And secondly, we told about nickel, palladium, platinum. Nickel is toxic. You know, when any nickel used as a catalyst for the hydrogenation. And Germany discovered it first. And then within 10 years, they had more than 100 industry for the preparation of the oils from non-edible fats. So non-edible fats to oils. So that oils becomes edible. And these new types of new varieties of oils they consume, particularly the people of upper class, since it is an scientifically advanced oil, so those are the rich men, they consume it. And after 10 years, all of them were suffering from liver cancer. Then it was identified that oil contains nickel residue, and this nickel residue is responsible for this liver cancer. Nickel is used, but because of this activity, nickel is stopped. Out of nickel, palladium, platinum, nickel its size is lowest, so it can easily penetrate into the product as well as into the cell. While platinum, since it is the costliest metal, and so platinum also useful as a drug. So platinum chemistry is there. It is not that platinum catalyst. Platinum catalyst is there, but it is a huge cost. So that's why people are interested to carry out the chemistry of platinum. Besides, platinum is easily oxidized to platinum 4. While palladium is not so easy to have a platinum palladium 4. You know, so that is another reason why palladium is versatile catalyst and platinum. Yes, palladium is reluctant to oxidize in platinum. Yes, yes, that's why we use catalysis.
सर अर्बन सस्टेनेबल डेवलपमेंट की बात होती है, लेकिन क्या ये संभव है, जैसा कि भारत भी है और पूरी दुनिया में कैपिटलिज्म है, तो क्या संभव है कि कैपिटलिज्म में सस्टेनेबल डेवलपमेंट हो सकता है?
Yeah, I am not a political person to talk about capitalism, socialism, humanism को का बात तो मेरा अपने नहीं है. See, capitalism, every reason, they are working with the humanity. If sustainable does not come, given society, civilization does not sustain. That is one of the capitalism has to do it. All the reasons, they have to do it. Otherwise, the society does not persist. Civilization does not persist. Okay, so we will discuss. Thank you. Thank you.
Good afternoon, esteemed distinguished guests, scientists, professors, research scholars, students and friends joined in this technical session 6 through online as well as offline platforms. It is my immense pleasure to deliver the vote of thanks. Organizing committee is deeply grateful to invited speakers who share the research work in this technical session. The first resource person was Dr. Deepan Bandyopadhyay from USA. Dr. Bandyopadhyay shared research work on quantum manifestation of nonlinear dynamics and quantum synchronization. The second resource person was Dr. Manish Devnath from CSIR IICV Kolkata. He shared his research idea about antimicrobial peptide machine learning system for host defense peptides as well as intracellular targets like DNA and RNA, and also they explained the the disruption of the cell membrane that kills the microbial cells by the peptides. And the third resource person was Professor V.N. Sharma from IIT BHU Varanasi. Professor Sharma shared research idea about metal AM process and focused on the fabrication and their application. The fourth resource person was Dr. Tanmay Banerjee from University of Bardhaman. He shared his research idea about a story of non-linear world in my in very simple manner. And the fifth resource person was Professor Jyotimay Das. He shared his idea about the therapeutic application of nucleic acid, and then explain the quadriplex DNA, that is tetrahelical DNA, and that is the macrocyclization, and also they will explain the immunocytochemistry, and also get the idea detailed about the MIC, minimum inhibitory concentration, and this technical session 6, the last but not least, the resource person was Professor Chitranjan Sinha sir, in the offline mode from the Jadavpur University as well as Indian Photobiology Society. He delivered his talk on the towards sustainable development goals through the advancement in sensing probe for the public health. He explains in a very simple manner about the biological role of metal ions, also explain the impacts of the arsenic and fluoride toxicity in the public. Again, especially thanks to the Professor Chitranja Sinha sir for the introduction during the session. Thank you all. I would like to express appreciation to the technical staff, Avneet Bhushan, Chandan, and Dr. Manish for the technical support. I also acknowledge the audience for their participation in the session. I also extend a heartfelt thank you to all of you for being here and making this session memorable and wonderful. Thank you again.
Actually, our lunch session will start at 2 o'clock actually. So within 10 minutes, one or two lecture we can accommodate 5 minutes for the oral presentation. Can you present now? Presentation. 5 minutes, 5 minutes. Otherwise, we have to wait. We will run for parallel. We will run parallel session in the next technical session for faculties in conference hall 1 and the speakers in this hall. So we can continue that also. Just wait few minutes because lunch will be ready within few minutes. We will go together. Actually, we will close that door and first we will enter. Then we will arrange your food. Then we will allow other persons. So first we will arrange like this. So wait for their instruction. Then maybe after lunch, maybe just wait. I will check.